As much as life has changed over the last year, you're still pretty busy, so consider convenient COVID-19 testing from Quest. Get the same tests hospitals use without a doctor visit. Simply order online, select from drive-through or at-home options, and get results sent securely to your phone or computer. It's a great fit for your busy life. With over 25 million COVID-19 tests processed, you can count on Quest. So order your test today at questcovid19.com. That's questcovid19.com.
Welcome to Star Talk, your place in the universe where science and pop culture collide. Star Talk begins right now. This is Star Talk. I'm Neil Degrasse Tyson, your personal astrophysicist, and for this edition of Star Talk, it will be Cosmic Queries. I think it's a grab bag edition, but I got to check with my co-host, Chuck Nice. Chuck.
Yes, what's up, Neil? And you are correct, sir. So the first query has been answered.
First query is, what are the queries about? So what happens is normally we solicit topics, but others sort of dribble in and they sort of collect.
Yep.
We're housekeeping really by tending to the questions that are completely random, coming from every compass direction of the universe.
Which is good too, because people get very upset when their questions go unanswered, but they don't realize that when we're soliciting new questions, it's because it's a different topic, like you said.
It's a different thing, right?
So, it's not like we can just continue. So, you're right. This is a great way to do some housekeeping and make some people happy.
So let's do this.
All right.
But wait, just before we begin, so what does a comedian do in the shutdown coronavirus? The clubs are closed, right? So you just tell jokes to your wife and your kids?
No, they don't want to hear any of my... my kids don't even the worst day was when I walked in and my wife was like, "Oh, good, you're home. Let's watch." And there was something I had done, some TV shows that she had taped, and she didn't watch it just so that she could watch it with me. It was like the first episode of something I was on. And both my children, I have three, but two of them were sitting, and they both, like without cue, they went, "Do we have to?
But Daddy's on TV again.
What do we gotta watch this guy?" And my son goes, "He's right here." So funny. Yeah. No, I mean, I'm actually just doing the only thing that's available, which is remote voice work. So
okay. Yeah, you got a good voice for that.
Yeah. So I can't say which, but I've booked several commercials. I can't say which ones yet because you're not allowed to say what commercial you're on until it actually airs, and they won't.
This is just a Star Talk audience. We won't tell anybody. Just between you and me and the.
Don't worry about that NDA you signed, Chuck. So so just look for my voice on a couple things, that'll be.
Oh, wait, have commercials risen to the point where they have NDAs? I can't know what the hell you're just advertising.
Yes, yeah. It's really strange how secretive and like how just overbearing you might say. But then when I think about it, you're talking about, if you look at the industry as a whole, billions. Of dollars.
Billions.
So
billions.
All right, let's jump right into this. Of course,
give it to me.
Patreon's first, always with Patreon. Mm-hmm. So let's start with the Patreon patron. This is Abdul Aziz bin Rajab. And he says, "Hey, quick question. What form or thing can sustain itself and not be destroyed by a black hole? Or what thing can sustain itself the most, and to which degree would it be able to hold itself together when entering a black hole?" So is there anything that can withstand your term I'm about to use, is there anything that isn't spaghettified when it goes into a black hole?
No.
Ooh.
Next question. No, so what happens, it's a very simple calculation. Normally when we think of materials, we have eggs that'll break, or steel that's strong, or rubber that's flexible. So we have these sort of macroscopic descriptors for these things in our lives. When you analyze it at a molecular level, because that's all the black hole is going to care about, and then the atomic level, as you fall towards the black hole, what gets you is what are called the tidal forces. These are the forces that will stretch you head to toe as you fall in. Are you sure you want to go?
Yeah.
That's an old rhyme I penned 30 years ago. But anyhow, so what's happening is the part of you that's closer to the black hole singularity feels a stronger gravity than the part of you that's farther. So in a feet first dive, your feet will start falling towards the black hole, towards the singularity, faster than your head will. That's not a good situation to be in. Initially feels like a stretch. You know, who doesn't like a good stretch? But then you realize that it is unrelenting and growing. And it reaches a point where the tidal forces exceed the molecular bonds that hold your flesh together. Then you snap in two pieces, your upper half and your lower half of your body. But you might say, well, how about a brick of steel? Yeah, steel is held together more strongly than your body is, but there's still a breaking point for the atoms of steel, for the molecules that make up the steel. Sorry, the carbon, the iron, and all that comprise the alloy that is the steel. They're connected by some force, and you can calculate what that force is, and there's a distance from the center of the black hole where the tidal forces will be so great that it'll rip apart the molecules and the atoms of your solid block of steel. Yes, that'll happen closer in than what would rip you apart. Yes, but it'll still do it.
It's still going to happen.
It's still going to happen. Not only that, it'll rip the atoms themselves apart.
Oh, snap.
And the nuclei. That's what I'm saying.
Oh man, that's serious.
That's evil. Evil forces. So this is where gravity wins over atoms.
Nice. So now let me just take Abdul's question and for my own edification, go a little further. So when you're looking at the creation of a supermassive black hole, when you get down to the place where it's the star that's dying is producing iron, and now there's nothing that can happen after that. So it's like, okay, I'm going to collapse in on myself, right? So now, the iron is already there. What happens as these things, or whatever it is, whatever matter it may be, falls towards this singularity? When it gets there, is it infinitely compressed? Does it have like a core? What is happening at that point, since you have these streams of particles that are now they're not even particles, they are just particles.
You say, where do they land?
Yeah, where do they go? That's what I'm trying to figure out. Where do they go?
So the only way to find out, Chuck, is if we send you. And then you report back. Okay, just report back. So here's the problem. Einstein's general theory of relativity, which gives us the large-scale structure of the universe and the Big Bang and black holes and the like, shows us that at the center of the black hole, the gravitational force exceeds everything molecular and atomic. And in fact, it compresses matter to a point of infinitely small size, which means it has infinite density.
Right.
Now, that's just crazy. So
that is crazy. That's inconceivable when I'm trying to think of it, but it can't.
Here's my point.
Yeah.
Maybe that doesn't happen.
Oh.
What I'm telling you is Einstein's general theory of relativity predicts that. So that could be the edge of where Einstein's relativity applies accurately to the universe. Maybe before it hits the singularity, some other law of physics needs to be invoked to extend our understanding of the universe beyond where Einstein then leaves us off. Okay? Newton left us off. Newton's forces operated under relatively low gravity and low speeds, and it failed at high gravity and high speeds. We needed Einstein to go into the dark closet of the unknown. But now we know in advance that general relativity has these limits. And so enter string theorists.
Right.
They come in and talk about the singularity. They've got a whole mathematical formalism to think about the singularity. And so Either it really is infinitely small and infinitely dense, or there's another branch of physics that still needs work, string theory still needs work, to give us an understanding of that particular regime in the cosmos. So, yeah, so the answer to that question is I don't have an answer.
Right. Well, clearly no one does.
What we do know, he didn't ask this, but I will tell you, what we do know is that we used to think or hope that if you went into a black hole, it's a portal to another place, perhaps another dimension, another universe itself.
Right.
The problem is, it turns out the information that entered the black hole will ultimately come back out of that same black hole through Hawking radiation. The black hole will basically evaporate given enough time. It'll lose its mass through particles, and the inventory of those particles that came out equals the inventory of particles that went in, which tells us that you can't take stuff, put it through a black hole, and have it show up somewhere else.
Wow, that makes perfect sense.
It still remains in this universe, and it's a remarkable discovery of modern quantum physics and black holes.
That's incredible.
Yes.
That is an incredible. Yeah, so the evaporation of a black hole through Hawking radiation kind of lets you know that it's not going anywhere. It's actually coming back out.
Coming back out. It's coming back out.
It's coming back out.
Coming back out. All right. And just so people, in case you didn't know what Hawking radiation is, you remember E equals mc squared. You'd learn this in elementary school. It's the equivalence of energy and mass. E equals m, energy and mass, and c squared is a constant. It's the speed of light, but it's actually not important about what I'm about to describe. So you can convert energy into mass and mass into energy. They're interchangeable. So it turns out in the vicinity of a black hole, the energy density of the gravitational field is so high that the energy will spontaneously create particle pairs. And it creates a matter and antimatter particle. One particle falls back into the black hole, the other escapes. And that's the slow evaporation. And you take the inventory of those particles, and it is exactly what fell in and got spaghettified in the first place.
That's amazing.
Yeah.
Oh my God. Now wait a minute. So it just dawned on me then. So what you just described, though, the information, you called it information, that means that there's a change of information then.
No, wait, just to be clear. What's for me mind-blowing is matter enters the black hole.
Right, that's what I'm saying, yeah.
And then the black hole has gravity because of that matter, and the gravitational field, when it generates new particles, remembers the matter inventory of what fell into the black hole in the first place.
Oh my God, yes. That's amazing.
There is some communication in the system where the entire system remembers what matter it had eaten.
It has to, because otherwise it wouldn't be able to create the
same portfolio.
To put it off, to send it out.
That's great. So this, for me, that was the most amazing fact about that discovery.
Oh my God.
And it's upsetting to science fiction folks because you want to go in a black hole and come out somewhere else.
Yes.
So now we need some other way to go to leave the universe.
Oh, wow. Okay. Hey, man, great question, Abdul.
All right.
Much. All right, let's see. God, okay, here we go. Let's do...
Was that only one question? We're almost out of time for this first segment.
Who cares? Who cares? It's good stuff.
All right, go.
Keep going. It's just good
Keep
stuff.
going.
All right, here we go. This is Giannis Kiosis. Okay, I said your name wrong, man. Sorry. Giannis, though, you know who I'm talking about from Facebook. He says, what would be more groundbreaking as a discovery and why? Understanding dark matter or discovering life outside of our solar system?
Cool.
Or even Earth. You know?
Okay, so the dark matter question would be amazing. It's the longest standing unsolved problem in astrophysics. We're going on 90 years not knowing what dark matter is.
Look at that.
Okay. So, So if we learn what it is, that would be a great day in astrophysics. However, if it's simply another kind of particle that doesn't interact with our own and it's out there, that we're hypothesizing anyway, that's not as interesting as if dark matter were the gravitational effect of a parallel universe influence. So whatever it is, I'd want it to have far-reaching implications for me to get excited about it. Okay. Is it, if we know dark matter, then we know dark energy? And is there another thing? Can we unpack black holes because we know, is there some other thing that it comes with? Is there some package deal with other unsolved problems that get solved with it? If not, I'm going with the discovery of life elsewhere on an exoplanet. Because for two reasons. If it's made of DNA, either we're shared DNA and life got around in the early formations of solar systems, or DNA is an inevitable consequence of complex organic chemistry.
Right.
So that wherever you find life, it would then be DNA based.
Right.
Now think about it. Is that so much of a stretch? If you go to Mars, you find rocks that are familiar. Right. If you go to Europa, you find ice that you have seen before. So geology and chemistry seem to repeat. You see volcanoes on Io, one of Jupiter's moons. So why would biology have to be sort of unique to one place and not be a highly repeatable phenomenon? That's a fair question to ask. But I can tell you that, so it would be interesting if it was based on DNA. For both of those reasons, it would be even more interesting if it had nothing to do with DNA. Yet it still was life, self-replicating, thriving. That would be like, oh, we got to open up our definition and our understanding of what life is.
Right.
And then the biologists who, they celebrate the diversity of life, but behind closed doors, they got to be honest with themselves. You know what that honesty is? Oh, look at the diversity of life, plants and animals and fungi. And then behind closed doors, it's
pretty much the same. It's routine. It's nothing special, baby.
All life has one common origin.
Right.
So what you want is another genesis. And then you can compare and contrast. Well, life requires this, but doesn't require that. Well, we used to think life required a 72-degree tide pool, no, you have extremophiles doing the backstroke in acid under radiation conditions. So every new thing we learn about life on Earth tells us how hardy life is and how resilient it is to stress, to a system. Even if an organism dies, life in general seems to thrive. And so if we find life thriving under conditions undreamt of, with a chemistry unimagined, that would be a far greater discovery than just finding out another particle to add to the particle zoo that we then credit for being dark matter.
The particle zoo. I think I'm going to take my kids there.
Chuck, we got to take a quick break. When we come back, more cosmic queries. Galactic gumbo. No, you say it, Chuck.
No, galactic gumbo. They don't mean about saying them guarantee.
When we return. That was good. We're back. Star Talk. Cosmic Queries. Grab bag edition, but Chuck calls it something else.
Galactic gumbo.
No, gumbo's got a lot of different ingredients. That's why we're saying that, right? Because gumbo's got what? You got
you got everything. You got crab, sauce, you got corn, you got crawdads, you got sauce, andouille sausage.
Andouille, yeah, and you also have rice.
That's right.
Yeah, okay.
Oh man, I think I told you this. I don't know if we talked about it on the air or privately, but Yvonne Gagne, gosh darn man. Got to get you some Yvonne Gagne gumbo. She's a friend of the family from New Orleans who used to make gumbo that would.
So where is it? So I'm waiting for it.
You're like, don't talk about it.
Yeah.
Do something.
Clearly,
don't talk about it.
You have never mentioned it on or off the air because I haven't had it yet. I just want to make that clear. Okay.
There you go. All right. Well, we're gonna do that. Here we go. Let's go to Riam Samari, who says,
are we done with the Patreon questions?
No, this is also, from Patreon.
Still Patreon. Okay. People that pay their way to the top of the list.
Yes, they do. The American way, as we call it. Anyway.
You're so cynical. Chuck.
I know. I can't help it.
Man.
It's an occupational hazard. Oh. Okay, here we go. Riam wants to know this. He's very poetic. So I'm just going to read all this, everything here because he's very poetic. He says, the sky calls to us. If we do not destroy ourselves, will we one day venture to the stars? It was Carl Sagan's lifetime mission to encourage humanity to explore the universe. And you, Neil, are calling for the same goal and carrying the message to a new generation. Given the recent promising spaceflight developments of SpaceX, do you think that during our lifetime, we will finally see humans colonizing other planets, or at least finding a glimpse of intelligent life on other worlds?
That's beautiful.
Yeah. This is a guy who spends a lot of time reading your stuff, clearly.
Okay. So the answer is no. Next question.
Damn! oh, damn!
I'm just
This
saying.
just hurts.
I'm just being on. I mean.
Oh, that was a hot knife and twisted. Wow. He's so eloquently asked this very, just super optimistic question. And are you serious? Do you really think no?
Yeah. He said our lifetime? No.
Wow.
But can I tell you why? It's not, I didn't pull that out of my ass. I mean, I have reasons for this, thinking this. Okay.
Go ahead.
It's think about it. What other planet in our own solar system comes closest to anyone possibly living on it? Which planet?
It's none. Mars used to be.
Mars. Okay. Now, because Mars has polar ice caps, it has seasons, it's near us in the habitable zone. It once had liquid running water, doesn't today, maybe underwater, underground, permafrost, frozen. So, okay, Mars. You ain't going to Venus. It's 900 degrees Fahrenheit, 500 degrees Celsius. It's hotter than a pizza oven. You ain't going to Venus. You're not going to Mercury. It's almost as hot, okay? So, Mars. Do you realize that Antarctica is wetter and balmier than every location on Mars? Yet I don't see people lining up to buy condos in Antarctica. Colonizing.
That's because Superman's a lousy neighbor.
He's in the North Pole.
Is he really in the North Pole?
Yeah. Oh, okay. I'm pretty sure it's the North Pole. But there they showed land, but there's no land in the North Pole, so they got that wrong. Yeah,
that's okay. Right.
Santa is on an ice floe.
That's right.
Whatever's left of it. Okay. Santa's in a bathing suit right now, sipping pina coladas.
with a polar bear wearing sunglasses. You know what? We're laughing, but it's so sad. But go ahead.
It'd be excuse for Santa to get buff, right? If he's in a bathing suit on an ice floe.
Exactly.
Sipping a drink. We'll give Santa with abs. That'd be interesting. So we don't see that happening. So the urge to live on Mars would be novel initially, I think. Right. But to say, I want to live here forever, I don't see that happening. As an urge. You'll want to get back to Earth. You'll vacation there briefly, but you'll want to get back to Earth. And so I'm suspecting. So for me, what you'd have to do is terraform the planets first.
Wow.
Then they're Earth-like, and then you can go there and pitch tent, and you get off the spaceship, and you don't suffocate. When Columbus arrived in the New World as one of the first Europeans, I guess after the Vikings, when he stepped off his ship, he could breathe the air. He met other people here who greeted him. He could eat the fruit on the vines. He could repair his ship. Why? Because the trees in the New World were made of wood, just like the trees in Europe. So when people speak of the next generation of space exploration, analogizing to that era of explorers, you're missing the point about dying when you step off the ship. So it is supremely hostile to human physiology. That's all I'm saying.
Wow.
And And plus, if we do go to another planet and find civilizations, I like to think we've learned something about how to interact with people who are there to greet you. Who are already there. So, lessons from the Columbus chapter of colonization is if you do find other life forms, what's the playbook for how we're going to interact with those life forms, be they what we designate as intelligent or not. By the way, NASA has an entire branch of itself called planetary protection, which is if you're going to visit a place that might have life and send a probe there, you have to sterilize the probe completely so that if you sneezed on it before it was launched, you don't get rhinovirus on the planet that you're going to be exploring for life itself. And for any samples that get returned to Earth, they have to be quarantined to make sure that nothing then contaminates Earth.
Cool.
So that's my longer answer, but the answer is still no.
Wow. I mean,
to visit, yeah, but not to call. I don't see colonization.
Yeah, that makes sense.
Yeah.
It makes sense. Sorry, Riam. Sorry, buddy.
Yeah, okay.
Sorry, buddy. There we go. This is Brett Marshall from Facebook, and I just have to read this because I don't know why. He goes, "Hey, I'm still here, and I'm still too stupid to come up with a good question. But,
Okay.
but I listen to every show."
That's what it said.
Yes,
That's great. That's not the whole thing.
Oh, that's it. That's all he said.
Say it again. Read it again. I got to hear it again.
He goes, "Hey, still here, still too stupid to come up with a good question. Listen to every show. Peace."
Is he a Patreon member too?
No, he's
not a Patreon
He's
member.
coming to. He might be, but he's on Facebook. He's on Facebook.
All right.
Yeah.
I appreciate the sentiment, but by the way, I don't judge whether a question's good or not. In the end, is my answer good? You should be judging my answer, not whether you think your question is good.
Right.
Ask anything you feel. That's what matters here.
Okay. All right. Here we go. This is Dewan Only from Instagram. Hello, Dr. Tyson. How far do you think our advancements in science would be if the United States budget used for the military was actually used towards science and technology?
Oh my God.
What a question.
Oh.
Yeah.
Okay, so the budget, I haven't looked at the very latest budget, but last time I looked, the budget for the National Science Foundation was about $30 billion. NASA's budget's about $20 billion. So you put them together, you get about $50 billion. There are other ways we spend money on science. For example, the National Institutes of Health does medical research, this sort of thing. So if you add up all the portfolios in all disciplines of science research in America, you get up maybe 70 billion, maybe $100 billion in a year. That's a lot of money. The military spends $600 billion every year.
Oh, my
on the military. Now, a lot of that is standing armies, literally and figuratively.
Right. Yeah,
it's like, pay or play. It's like you want to fight a war? That's on top.
Right, exactly.
Right. War? I didn't know you want to fight a war.
Right.
We need more money for that. Okay. So it's not always true that throwing money at something at that high rate leads to a discovery. Sometimes you have to move through a place where new ideas percolate, germinate, and maybe those new ideas come from a wrong result. It could be a wrong result says, wait a minute, no, we were doing it wrong the whole time. It's really this. And you couldn't have had that thought unless you landed in a place where you had done it wrong in the first place. Some of this takes time. So I would say the way to think about this is they have peer review research grants. And so I write a grant. I say, I want to do this research. And it's going to take me this long. It's going to take me this much money. I want to hire this many people. I want to do it in this location. And they approve. Okay. So here's what happens. Depending on how much money there is and how many people are applying, you get to grant 10% of applications. Sometimes 50. Well, how about the other 85%? Well, you can say, well, these are just not worth funding. But these others were on the border and they should be funded, but we can't fund everything. You want money for those. Okay? Right. That would, I think, double what we're currently spending. So I would say, if you want as healthy a science budget as you have, given the number of scientists in the country, if you doubled all the science budgets, that would get us pretty far, pretty quickly. Now, how advanced would we be? Again, it's a matter of time. Okay, if civilization didn't spend so much time in the Dark Ages, or rejecting what science could have been, if scientists weren't sorcerers or people who had some knowledge of the natural world, if we weren't crediting oceans to Zeus or to the wrath of God or to other supernatural forces, and we said, no, wait a minute, maybe they're natural forces. Had that begun earlier, it's possible we might have been on the moon in the 19th century rather than in the 20th century. But again, it takes developments, right? You have to figure out, well, we need this new material. Where are you going to get? We have to dig for it. Well, where are we going to dig? Is the geology up to matched with that? And we have to understand the human physiology. Is medicine at that place? So it's very complicated. In a good way, it's complicated. I mean, you want a lot of different things happening, but you also need bridges and tunnels connecting these discoveries so that the next innovation can exploit what had come before in any discipline that it needs to make that happen. So I would say to punch science along at the rate it should, you'd have to double all budgets. And otherwise, yeah, we've probably lost a few centuries in the history of civilization.
Wow.
Because of people standing in denial of the role of natural forces relative to supernatural. Yeah.
And we're headed back there. So, yeah. There you go. So, way to go. Way to go, world. Way to go.
What did I tweeted recently? I said every disaster movie begins by people ignoring the warnings of a scientist.
That's right.
Every disaster movie.
Okay. Mm-hmm. This is N Jonesy 19 from Instagram. He says, can you please explain the horizon problem? It would seem that no matter where you are in the center of the universe, which means all locations are the center of the universe. That really begs another question. Is there a center of the universe? And how many licks does it take to get to the center of that universe?
If you're over 60, you'll remember that TV commercial for the Tootsie Pop.
No, they brought that back.
Did they?
You bought that? Yes, I'm serious. Yes, they did. How many licks does it take to get to the center of a Tootsie Pop or something like that?
Yeah, it depends on how slobbery you are. I mean, I knew that. I was a kid when I was 9. I said, it depends on how wet your tongue is. What are we even doing here? You know? I know what it was. It's because you'll bite it before you lick all the way. That was the... Oh, that's the
catch. Yeah.
Yeah, because you get the candy in the middle. So
what is the horizon problem?
Yeah, well, there's something, what he's citing is not entirely the horizon problem. So, but let me just explain horizons, right? When you're a ship at sea, and if you just look around, the distance from you to the last bit of water that you can detect is the same in every direction. And that distance is farther the higher up you are in the ship. So the quote, crow's nest, the highest point on a ship, is where the lookout person stood to look for icebergs, to look for land. They would be the first to see this because they have the farthest view over the curvature of the earth.
Land ho!
Yeah, exactly. It's that person who sighted it, not someone looking over the railing. So it's clear and understandable that if you're at sea, the horizon is the same distance to you in each direction. Okay. Now, another ship, also in the middle of the ocean, sees their own horizon. Everybody is the middle of their own horizon ocean. And what we don't know in our own universe is is there a point you can stand where your horizon doesn't go the same distance out? Does it end? And in principle, yes. In principle. But what I can tell you is that every direction we look, when we look 14 billion light years distant, we see the origin of the universe just now reaching us. So that means everybody at that distance, okay, at that time distance away from us, is experiencing the beginning of the universe. If in this direction they were not, and I saw a regular galaxy there, and in this direction I see them being born, whoa. That would mean I've land ho, okay? It would mean this direction is different from this direction. And if you're out at sea, if there's land that way, but sea in every other direction, water in every other direction, something different just happened. And so that becomes a more intriguing part of the universe. We'd all be focused that way if that were, in fact, the case. Now, the horizon problem, as stated, just the horizon problem, means something different from what he asked. And it has to do with if this horizon is very different from that horizon. There's several manifestations of this, but one of them is, how can that part of the universe be at exactly the same temperature as this part of the universe? How would it know to be the same temperature? Unless the whole universe was somehow connected to itself in a very small place. All right. And it had to be really connected because the difference in temperature in every direction is like 1/100th of a degree Kelvin.
Wow.
You don't have that consistency of temperature from one side of your room to the other, much less one side of the universe to the other. And so this is part of what we think of as the horizon problem. And this is where we got to inflationary cosmologies. So these are the details. That's in the, what do you call it, in the weeds of the Big Bang. When they say, oh, the Big Bang is having problems, there's just challenges within the weeds. But the broader picture that we began as an explosion 14 billion years ago, that's intact. It's like, what's going on in the weeds that we have to try to understand.
Interesting.
So, yeah,
wow.
Yeah.
All right. Well, cool.
We've got to end there. We've got one more segment left of Cosmic Queries. Potpourri. Cosmic Queries grab bag. Cosmic Queries
Galactic Gumbo. No home. Get it home.
Okay. When we return.
Hey, it's time to give a Patreon shout out to the following Patreon patrons: Nigel Adams and Caleb Salibi. Hey guys, thanks so much for all of your support because we could not do this show without you. And for those of you wondering how you might get your own Patreon shout out, well, go to patreon.com/StarTalkRadio and support us.
We're back. Star Talk Cosmic Queries grab bag edition. Let's do it.
All right, here we go. This is PN Wonders, who wants to know this. With Earth gathering mass from space material all the time, when will the mass increase to have an effect on Earth's orbit? And what would that effect be?
Yeah, that's a great question. So Earth plows through, in our orbit, Earth plows through several hundred tons of meteor dust a day. Hundreds of tons. Okay, so write down that number, several hundred tons in a day times 365 days times 4 billion years, and figure out how much mass that is. And then compare that to the actual mass of the Earth. That's like a gnat flying full speed ahead into an elephant, and the elephant says, "Hey, quit the shoving." That's not going to happen. It is uninterestingly small relative to the total mass of the Earth. So no, not to worry about.
So nothing to worry about there. Negligible, as they say.
Sleep
well tonight.
Yes.
PN Wonders.
Oh, by the way, there's something else happening. The sun is slowly losing mass through solar wind. You've heard about solar wind? These are particles. Right. Where's your concern about the sun's mass? Well, the sun is actually getting lighter. And as it gets lighter, the speed with which we are in our orbit is too fast to maintain that orbit, and it goes to a higher orbit. Okay, so in fact, the fact that the sun is losing mass is making Earth slowly spiral away from it. And the sun will lose mass at an ever faster rate as the billions of years unfold. And we'll end up, all the planets will end up orbiting farther and farther away. It's one of the fates of the solar system.
The solar system is a cruel, cruel mistress.
It's crazy.
Yeah. God. All right, here we go. Bugger Dude from Instagram. Bugger Dude says this: how did astronomers find out that the edge of the observable universe is 43 billion light years away?
Okay, so let's resolve this. So most of us, we astrophysicists, when we think of the edge of the universe, we say it's 14 billion light years away.
Right.
That's not really true. Okay. The part of the universe we can see, the light that was sent by that has been traveling for 14 billion years. But that thing that emitted the light, that's not 14 billion light years away right now. It has been part of the expanding universe and is now 40, low 40, 43, 45 billion light years away in that direction, and 45 billion light years away in that direction. So I want to speak of the diameter of the universe. You're talking 90 billion light years. You just don't observe that. And so much of my field tries to anchor itself in what you can see rather than what you calculate to be true. So yes, we can calculate how far away that galaxy is that we're watching right now being born 14 billion years ago in the Big Bang. Where is it today? It's a full-grown galaxy. It's full red-blooded galaxy, and there it is, or green-blooded if it's got copper for its hemoglobin. And there it is, 45 billion light years away, and you don't see it there. So that's how that works. So you have to calculate based on the known expansion rate of the universe where that is today.
Right. So basically, the cosmos is an annoying grandmother that pulled out an album of baby pictures. Yeah.
I guess a little bit. And who pulls out albums of anything? Yeah. Chuck, how old are you?
Oh, I still keep. I print out my photos and I put them.
Hence
in an
my
album.
question: how old are you?
Well, it's the same as scrapbooking as far as I'm concerned. It's like because you know why,
ladies and gentlemen, Chuck is 75 years old. It's just that black don't crack, so he looks good. Mm-hmm.
And you know what? I need some tea. I'm cold and I need some tea.
And your rheumatism is acting up. And it's going to rain tomorrow.
Well, it's going to rain tomorrow. All right. Yeah. Yeah. No. Okay. So here we go. This is Ashkat, and his last name. Yeah. Patrikar. Okay. Patrikar. All right.
It takes you that long. You have to think about that, Chuck. You're not just you have to read it and think about it and then say it.
Yeah, because I mean, you know.
Okay, all right.
Yeah. Hello, Dr. Tyson, and hey, Chuck, please pronounce my name right. Wait a minute. Akshat. Okay, dear Akshat.
Oh, he gave a phonetic. He
gave me his. You know what, Akshat? Thank you, my friend. He gave me. There you go. He says, my question is that about 400 years ago, Sir Isaac Newton, hey, Neil, I know that's your man, discovered the laws of motion and gravity. He also discovered calculus and had already discovered the laws of optics. How was he so focused and deeply indulged in his work during the plague, which was a pandemic during that time? How was he able to manage his mental health? And how can we manage our own mental health and have a spark of our own creativity and imagination during this time of peak anxiety? And Akshat is coming to us from India. Love from
thank you, Akshat. So first, I don't claim any mental health expertise, but I do know a little bit about Isaac Newton, and I know a little bit about others who have made singular contributions to our understandings of the natural world. And one of the things they all had in common was that they had episodes in their life, either thrust upon them by Isaac Newton escaping the Black Plague in London and in Cambridge. He was a professor at Cambridge, or at least in school at Cambridge. Or if you have an injury that sort of lays you up for a period of time. All of these people had long periods of time where they were in solitude. And so the brain just explored on its own. Today, other than families that have many young kids running up and down, so there is no solitude and everyone is quarantined together, there are others who just can't go to work and you live alone and you can't go to the bar or the club. So what are you doing? Are you sitting alone on the couch thinking? Or are you binging on the latest Netflix series? So we live in a time where many people's creative juices that might have otherwise flowed are arrested because they have distractions in their life. evening television, on-demand television, streaming services. So I lament, I wonder what discoveries remain unrevealed by brilliant people today simply because of the distractions we have built into our own lives. And the distractions are fun. They're not chores. We enjoy them. All right. And sitting alone by yourself, staring into the ceiling, no one would call that enjoyment. But that's exactly the conditions under which Isaac Newton contemplated the cosmos. And Darwin contemplated the cosmos, his long walks alone in the woods. No, there wasn't a TV screen. There wasn't advertising. There wasn't, I got to get back and watch, Westworld. No, none of that was going on in their lives. So if you ever had a chance of making such a discovery about the natural world, I don't think it's going to happen while you are distracting yourself with modern media or hanging out on Facebook or anything else on the internet. It's just not. Unless something there gives you an idea. You could be a fertile person and, that's an idea, but then you step away and develop the idea. How about that? Okay, so for me, that's what's behind that. And one of my great disappointments in the coronavirus quarantine is I'm not giving myself enough solo time because I'm catching up on email and I'm doing it and I'm cooking and I'm perfecting some recipes. Both my wife and I, we both like food. So we're doing that. There's some other things, but it's not quite, let me just be alone and think and write. So I'm failing on that myself. And plus not everyone is Isaac Newton, so.
Well, yeah. That's an understatement.
Yeah. Well, by the way, Isaac Newton, all evidence suggests that he was, I don't want to call it quite a misanthrope, but he did not really enjoy the company of other people. He never married. He never had kids. So if you don't enjoy the company of other people, then being sent to the country home in Lincolnshire away from other people, that's a godsend to you. Right?
Yeah.
And so, yeah, there you have it.
I forget who said this, but there's a writer and she said, the greatest impediment to creativity is distraction.
Oh, yeah, sure, definitely.
Yeah, and basically right along with what you just said.
And there's another saying, which is, if you want to be more creative, then become less productive.
Right, yeah. Now that's where I'm a Viking.
Where do you? Because when you say, I went shopping, I did this, I made, and look how much I got done today. Well, did you create anything? Chances are the answer is no.
Yeah. Well, you don't give your mind a chance to do that. So yeah, right. Yeah, cool. All right. So here we go. This is Alfredo Baldo Castiano, who says,
"Oh, you're showing off now. You're getting in the mood."
Yeah. He says, "Dear friends, I have a black hole question. If a black hole is a point of infinite density, that means it can bend the space-time so much that a particle falling inside can accelerate so much that it can reach the speed of light." Now, he put a question mark at the end. He wrote it as a statement, but he's asking it as a question. So, if a particle falls into a black hole, is the gravity so strong, since light can't escape, will it cause the particles coming in to reach the speed of light going in?
They'll come close, depending on how far away they emanate. But no. No. The answer is no. So you can calculate this. So if the escape velocity is greater than the speed of light, it means just put it right at the speed of light, just for this example. If you went the speed of light, you can escape the black hole. It'll keep tugging on you, slowing you down, but you'll reach infinity and have zero speed there. It's weird to speak on these terms. If you had more than the escape velocity, you'll reach infinity and still be going. Okay? If you have less than the escape velocity, it just pulls you back. So it depends on what distance you fall into the black hole from. And you can calculate what your speed is, and it's not, in most cases, it's not anywhere near the speed of light for that. So
gotcha. So the answer is basically nope.
No, yeah.
All right.
And by the way, a lot of material spirals into the black hole.
Really?
this. It doesn't just, yeah, because that's, you see these discs of matter
Oh,
that
the accretion.
swirl. The
Right.
accretion disk, very good, very
Yeah.
good. I got an accretion disk of my own right here.
That's you and your wife are cooking. See, this is the results.
Good accretion disk cooking. It's another cookbook, right? Maximizing the accretion disk. So in fact, most matter that falls into a black hole is spiraling in. It's not just falling straight in.
Very cool. This is FLVOQ. I don't know what that is. From Instagram, he says
it looks like a random hits on a keyboard.
It really does. FLVOQ. He says, while I was listening to the podcast, I heard about nuclei getting spaghettified. If the nuclei get spaghettified, here we go. What about the quarks?
I have an answer for that. I don't know. I have to. If I were to guess, I would say it also spaghettifies the quarks.
Wow,
because it's pretty bad down there.
That is really nasty, man.
It's nasty. It is.
I mean, you are literally tearing an atom apart.
Well, wait. So you tear the atom apart by ripping off the electrons. That's nothing. Okay, electrons are easy.
Yeah.
But then the nucleus, which is very tightly packed, that gets spaghettified. And they're asking, now that you've spaghettified the nucleus, now you have the nuclear particles, protons, neutrons,
and then you got to pull them.
Quarks.
Right.
Now, and so I think the answer is yes. But pull in Jana to see what she says.
That's pretty wild. Okay.
But I think my answer is yes. Nothing.
Right.
Nothing survives a black hole.
Wow. Damn. That's really just disturbing.
You know what'd be fun? It's a good poem that needs to be written. Ready? Everything falling into a black hole gets spaghettified, except spaghetti. It's already spaghettified.
It's already spaghettified.
So it goes straight in. It's got no problems.
No one thing should have all that power. That's all I'm saying. That's a lot of power. Okay, this is
what else you got?
Teague Gwethan. People are making up stuff now, man.
And Chuck, this has to be the last question because we're spending too much time luxuriating on these answers. But
it's okay. Here we go. Teague Gwethan from Instagram says this. What are your thoughts on the simulation theory? How likely is it that it exists? Now, so.
Okay, I'm happy to end on that because my thinking on that changed in recent weeks.
Ooh.
And Chuck, did we do an explainer video?
We did.
On that?
Yes, we did. That's why I said go ahead and do it. So
yeah. So I now think there's a better chance that we're not in a simulation than I had previously imagined.
Okay, good. Now let's stop there and now go find that explainer so we can get more views on YouTube. And I'm going to say, and Michael Bruce wants to know this. How can we... Yeah, that's right. Now go find it. Go find that explainer on YouTube, and we're going to get more views. We're going to get more views now. So Michael Bruce wants to know this.
And while you're there, subscribe.
Make sure you subscribe. So Michael Bruce wants to know this. How can we prevent a mass extinction event when the world governments believe more in listening to who pays them over scientific fact? Wow.
Oh.
So a different question is, how do we elevate science to a place of respect when it comes to our leaders in government?
I wish I didn't have to say this, but maybe science needs better advertising.
Ooh.
Politicians can get you to like them just by a series of ads. Maybe we need that for science. There's science in your life that you don't even know is in your life that's keeping you alive and breathing. Most people who are alive today are alive because of some scientific advance in food production, in prenatal care, in health, in sanitation. I think people, it's easy to take something that's so embedded within your life for granted. So once you do that, then people will then see and understand what science is, how and why it works, and then they'll respect it, and then we won't go extinct from short-sighted politicians. I hate to say that because science shouldn't need advertising,
right?
But maybe we teach people, maybe if you teach them to constantly see and embrace it, then you don't need the ads. Teach them that in school. And so every day it's, hey, that's science. Hey, that's science. Hey, if you do that, then it's built into the system. So, by the way, when we were going to the moon, every day you were reminded what science was because we were going to the moon. You didn't need you didn't need someone to say, "Oh, we need more science teachers. How do we attract them?" People were climbing over themselves to study science. It's just, and technology and engineering and math because they saw the fruits of that in that era. So, yeah, I don't have a good answer. Extinction may be in our future for that very reason.
I'm science, and I approve this message.
On that happy note, Chuck, we got to call it quits there.
Alrighty.
This has been Star Talk, Cosmic Queries. Chuck, as always, thanks for being my co-host.
Of course.
Neil deGrasse Tyson here, bidding you to keep looking up.